Larry Cleeple here, filming for the Wise Fools Garage. So today we're going to look at a Corvair oil leak that is sort of common these days, but really wasn't common back in the Corvair's heyday. So it's not really documented in any factory shop manual. It's just something that we know today because of our past experience with Corvairs in all these years. And I'm talking about an oil leak here that is seen dripping from the very back of the motor. This is the back of a Corvair motor. You guys who look at it say, oh, that's the front of the motor. No, it's not. Remember, like I said in an earlier video, all references are made if you are sitting in the driver's seat. So this is the very back of the Corvair engine. And it's common to find oil dripping from the skid plate area at the back of the engine. There's a lot of stuff going on the very end of the engine here. You've got your oil filter here. You've got your harmonic balancer, so there's a seal behind it. You've got the distributor here, so there's a gasket underneath that. You've got this adapter plate that holds your fuel pump and your generator or alternator, your oil filter, all that stuff. It's got a gasket. You've got our oil cooler in the very end of the engine here, which has a couple of seals on it, which commonly go bad because they're taking all the heat of the oil. So the original neoprene ones get hard as a rock, just like the push rod tube seals. That's a common leak point. The oil cooler itself could leak. There's an oil pressure regulator, and it's got a gasket underneath it, almost like a drain plug type thing. And if we slide off our skid plate here, now we expose our oil pump, and it's cast into the aluminum housing, but it's got a steel cover plate on it, and of course there's a gasket here. And then this whole rear housing, if we were to take the whole housing off, there's a gasket between it and the crankcase. So we got a lot of stuff going on at the back of the engine, which means a lot of potential for leaks. So how do you tell where the leak is from? The best way I have found over the years, if it's not obvious, first thing you want to do, spray down the back of the engine real well, whether you do it at if you got a pressure washer, you can spray down the back of the stuff real good. If you don't, what I have had good success with is to look at the area from the bottom up, because you can only see half the picture if you're looking from above. But if you look from the bottom up, because that's where the oil leak's going to go, it's going to go out the bottom. And the way I do that is I'll jack up the back of the car, put it on jack stands in the appropriate place. Places, plural. And then use a wide 2x4 and your floor jack to jack up and under the end of the oil pan so that we release the pressure on the motor mount. Okay, we want to support the weight of the engine, not the weight of the car, just the weight of the engine with our floor jack. And then we're going to take off our bolts that hold our motor mount plate on to the motor mount, take off the motor mount nut or nuts that hold the motor mount plate to the motor mount. Then we can take off the motor mount plate and take off the skid plate as we just did. Then I put a couple of flat washers on our studs that come out the back and put the motor mount nuts back on. Do that on all four, tighten them back up. That way we're securing the bottom of the rear housing properly to the engine so we're not creating oil leaks by not having that area torqued down. And then I would start the engine up. Now the engine's running, idling. You can see from the bottom up where the oil leaks might be coming from. If it's an oil cooler leak, you'll see that the oil will be kind of trickling down from the, as viewed from the rear, from the right-hand side of the oil cooler, and it will be getting this piece of shrouding here wet underneath it on either the back side or the front side of it, because that's where the oil cooler seals are at. So that's a common spot. Oil filter leaks will be pretty obvious. They'll be dripping off the bottom of the filter. Rear housing seal probably won't show up too much because of the location of that but that will show up when the engine is sped up. You'll see that it starts to fling oil out the sides, and you'll see a line of oil on your two damper doors. That's a good indicator of a seal leakage. But I want to talk about one that is not obvious, and that is the oil pump idler shaft. What the heck is that? That is a steel shaft that's pressed into the aluminum rear housing, and one of the oil pump gears sits on it and spins. The idler shaft is what keeps it centered. Okay, well, that's a steel shaft in an aluminum housing. Does that sound familiar? Like the steel valve seats and our aluminum heads? By now, it's pretty well known that that's kind of a problem on Corvair heads when they get a lot of miles, a lot of heat cycles, is the valve seats can fall out because they've lost their press fit. The same thing happens with this idler shaft. It loses its press fit in the aluminum housing, but the effects of that happening are not catastrophic, not immediately anyway. It loses its press fit, and what happens is after the engine gets warmed up and the oil gets nice and warm, oil will start to come out the top of the shaft and then start to run down off the housing, and you've got an oil leak. This will only show up after the engine gets to full operating temperature, when the oil has warmed up. You're going to ask, how did that get so hot like that? That's not in the combustion chamber or anything. Well, remember, your oil pump is right here. Your oil temperature on a Corvair is typically going to be in the 200-ish range, can be hotter. It gets a lot of heat over the long run. And like I say, with the dissimilar metals, different expansion rates, loses its press fit, so that the idler shaft doesn't fall out or pop out the top, but it does fail to seal the oil pressure, because this shaft now is actually under pressure. It starts to weep out of here and drips onto the ground, basically. And that one's kind of hard to find. If you did a little running test with the engine idling and got everything nice and clean, and you've run it for 5 minutes, 10 minutes, man, this thing isn't leaking a drop. But you go take it for a half-hour drive and come back in the driveway and say, man, I got this oil leak all fixed. And you came out about 5 minutes later and you go, damn, this thing's got a drip underneath it. Where did it come from? Well, this is a good possibility, because you're not going to see that leakage begin until the engine has run long enough to get the engine oil hot and everything expanded. In the shop here, when I ran them, I typically had to run the cars on fast idle, maybe 20 minutes or so before the oil temperature got high enough that I'd start to see oil weeping out of this hole. So what do you do about that? Well, it can be fixed. It's not that big a deal. You're going to have to take off the oil pump cover, obviously, 6 bolts here, and obviously you're going to have the motor mount plate off and the skid plate area. So you're going to have the car supported on jack stands, so it's up in the air, and you're going to have the engine supported so you can take off those parts that are holding the engine up. We don't want to lower the engine or raise it any within the body. We don't want to disrupt the engine perimeter sealing strips. Okay, very important. So once it is properly jacked up, we're just going to take the bolts off the oil pump cover, 7/16 head socket will do it. Spin those babies off, not to them. Once they're off, we're going to see the inside parts of here, which is going to be our 2 oil pump gears, and of course the cover that's going to fall off in my hand. Okay, simple deal. It will leak some oil out. Be prepared with some sort of catch pan or something. It's not going to be a bunch of oil, but it will be some oil that leaks out of here. We're going to get a little pry bar sorts, screwdriver, something to help pop that off. Here we go. Okay, hardly anything came out. We're getting a little bit of oil in here. So what we're going to see inside is our two oil pump gears here. One of them is keyed to the distributor. The other is on the idler shaft, which of course is stationary. So we're going to set our oil pump cover aside because we're going to have to clean off all the gasket material on it for reinstallation later. Then we can pop out our gears on here. They'll just kind of slide right out if we can get a hold of them. There we go. There's our idler one. And this one is going to have the shaft on it that goes to our distributor. Of course, while you're doing this on the car, these are going to be kind of pointing downward. You're going to have gravity on your side, and when you take the cover off, they'll probably fall out. Okay, so those are our two gears. We'll set those aside. Okay, then what's left in here is our idler shaft, and that's the part that we're going to have to deal with to fix our oil leakage problem here. Now, when it's a housing like this, that's already off the car, this would be a pretty simple job to just knock this idler shaft right out of here. But when it's on the car, we have to do just a little bit more work. We've got to get our harmonic balancer off because you couldn't knock the shaft from the bottom up because it'll run into the balancer, and you really can't knock the shaft from the top down with the balancer in place. So the balancer's got to come off. All right. Since you've got the back of the engine more or less visible, you could use a conventional harmonic balancer tool to remove that. But there is a great product that I would highly recommend. This is a harmonic balancer tool, removal tool made especially for Corvairs. This is made by Blue Chip Tools, and he's got a lot of great Corvair specialty tools out there. So I'm first going to take off my harmonic balancer bolt. Now I'm going to do this for simplicity's sake with an electric impact wrench. But if you don't have that, there's another way that you could remove it, and I'll show you that. All right, so I've got my bolt off. Now let's say you didn't have an electric impact wrench or an air impact wrench, and you put a wrench on here, and every time you tried to turn the wrench, the whole thing turned. Okay, that's not a big problem. I would get a hefty screwdriver or similar tool, put it inside the spoke here of your harmonic balancer, and as you start to turn it, it will get to a point that your tool, screwdriver, drift, whatever it is going to jam up between the rear housing and the balancer, and then you'll be able to break this loose. So that's how you're going to loosen that with a conventional wrench or a breaker bar to spin it loose and break the center bolt loose. Once it is loose, then you can spin it out pretty easily. Next, as I say, you could use a conventional removal tool, but this is so slick. The advantage of this particular Corvair only balancer tool is you can do this on most Corvairs with the engine fully in place. You do not have to take off the rear motor mount or the motor mount plate, and you don't have to lower the engine, anything like that. You can do it with the engine totally in place, and that is a huge, huge time saver, absolutely. So to set this up, it's got two 3/8 bolts in here that come with it. They're short bolts. They screw right into the two existing holes on the balancer. Now, if you've got an air-conditioned Corvair or Corvair smog pump, obviously you've got a second pulley on here that would have to come off. It comes off the same way. It's held on by the center bolt and then the two smaller bolts for the second pulley. So it can be done on those models. If you've got a Corvair truck, you're going to have to take off that rear motor mount plate because there's not enough room on the truck to do it. but you can still use this tool. It's pretty slick. Now I'm just going to turn my center screw here with the 3/4 bolt in the middle, and I'm using this instead of my tool for the impact wrench, just to show how you could be doing this in your car with it all in place. Simply spin this baby off. It's pushing the balancer right off, just like you'd be doing in the car. Did I mention that you should have the oil filter off to do this? Obviously, you'd have to have the oil filter off. Because, as you also may know, that when the harmonic balancer fails, what happens? The outer ring starts to come off the balancer, and what's the closest thing to the balancer? The oil filter. And guess what that outer ring does? It saws a hole in the oil filter. So, word of caution, a harmonic balancer is a maintenance item when they're this old. Anybody who's got an original balancer like this one, this is like driving on a 50-year-old tire. It is. It may work today, but they will fail. So certainly you'd want to replace any old balancer with a new or rebuilt unit, because they will fail. The rubber fails, the outer ring comes off. And if you don't catch it immediately, saws a hole in the oil filter, no oil pressure. So we're going to set our balancer aside. Next thing we're going to do is we're going to get a suitable drift to put right on the top of our idler shaft here, and we're just going to knock that baby out. Now we can do this fairly easily. And you're seeing it's not taking a lot of effort to get this out. Okay, I didn't have to hit that very hard because they're not in very hard because of the it's lost its press fit. So our next step is we're going to want to clean this area up, and we're just going to move to a next scene here. I'm going to use some brake clean to clean the area inside of the oil pump shaft, and we're going to clean the shaft itself. Okay, we're going to work on our separate rear housing here so you can see a little better than our engine that's sitting on the floor what our next step is. So to this point, we've knocked out our idler shaft out of the rear housing. We've cleaned up the oil pump cover. We've cleaned up our gasket surface on the rear housing so that they're ready for reassembly. So what do we do to seal this thing up? We know that our idler shaft has lost its press fit in the rear housing, so if we simply knocked it back in, we haven't changed anything. In fact, we probably made it worse by knocking it out. Our answer is sleeve retainer. This is a special compound that will take up the difference in here and restore the press fit. This particular one I'm using is Permatex number 64000. Loctite makes a similar product, number 620. Both of them are applied and they will cure within 24 hours. And they are good to 400 degrees temperature, which is well beyond our needs here. If you get your Corvair engine rear housing at 400 degrees, that seal is the least of your worries, because you can have all kinds of problems with your motor, and that's only going to be one of many. The Loctite has a similar temperature range on it, actually a little higher. I think it's at 425 or so. So either of those products will work fine. You can buy them in different sizes. This is the bigger size. For this small area we're doing, you can get the smallest size, which is only a 6 milliliter tube. So I'm going to take this sleeve retainer. This is the Permatex style, which is kind of a green material. I'm going to put it over the area that's going to be in the rear housing. And I'm going to also put a similar amount inside the rear housing itself from both sides so I can get the most amount of contact area. Okay. And I want to make sure that I don't have any running out on our surface here. Now when we push this in, we probably will get some, so we're going to wipe that off. So I'll simply start that in the hole, and I'm going to tap it in place. How far do I want to go? Well, it has to be at the minimum flush with the surface. So let's just check this with a straight edge here. And indeed we are slightly below flush on here. So it's got to be at least flush. And another telltale of how far to go with it is that the top of the shaft is not quite flush. The top of the shaft is not quite flush with the aluminum housing. Okay, it's a little bit below the aluminum housing. If you tap it in till it's all the way flush with the top of the aluminum, you probably went a little bit too far. So be careful as you go in. Okay. At this point, I'm going to wipe off our excess amount on the outside just for cosmetics, but especially on the inside because we don't want any of the retainer to get on our gear surfaces. I mean, you can get it on there, it's not going to hurt it, but you got to wipe it off. We don't want any to remain there. So that's our important factor of getting whatever spilled out, so to speak, out of the area where our oil pump gears are going to be. Now at this point, we're just going to let our sleeve retainer do its thing. It'll cure, and we're going to put the rest of this back together. We can put the rest of it back together right now. We don't have to wait for it to cure to reassemble it. So the thing that we want to have is our trusty, well-used Corvair shop manual. In the engine section, we're in the engine rear housing section, and it gives a nice exploded view of our complete rear housing and also our instructions of how to set up the oil pump. And they're okay, but they're not completely with all the information that you need. The other thing you're going to need is some oil pump gaskets. Now these come with the complete engine gasket set. They come in different thicknesses. Okay, there is readily available from Clark's. There is a 3 thousandths, a 5 thousandths, an 8 thousandths, and a 10 thousandths thick gasket. Okay, why are there so many gaskets? Well, when we put our oil pump all together, we want to have a certain amount of clearance in here. Now we can't change anything between the housing and the gears themselves. Okay, that's non-adjustable. Hopefully the housing here isn't all scarred up and nasty inside, indicating a lot of trash has gone through the engine. But that's not a typical problem that we see. But the gasket here is going to determine our end play between the gear and our cover. And that's important because if we have this too tight, our gears are going to be wearing hard against the cover and we're going to have a notable groove in them. Okay, this shows a little bit of wear mark, but I can't catch this with my fingernail here. It's not bad enough to worry about. But if we have it too loose, there's going to be a lot of clearance between the gear and the housing, and that's going to let the oil kind of circulate between it instead of between the gears and make pressure. So we could have a low pressure situation with our oil pump if it was not assembled correctly. So how do we tell which one to use? Well, we're going to have two ways to do it, and one of them involves a material called Plastigage. You probably have heard of Plastigage before. It's commonly used when assembling the engine bearings to the crankshaft, so we know how much clearance there is, because again, the clearance is critical. Too much, you get a knock and low oil pressure. Too little, you could ruin the bearing and ruin the crankshaft. So it's common for that, but it's also going to help us set up our clearance on our oil pump. So one thing I would do as a test before we even start to use the Plastigage is I'm just going to get out the thinnest gasket here, which is only the 3,000ths gasket. And I'm going to set this up on our oil pump and just kind of snug it up, and we're going to try and test spin it and see how hard it is to turn the oil pump gears. By doing this test, you'll know if you're in the ballpark or not for your for the correct gasket. So we're just going to put all these in here and tighten it up, and we're looking at our shop manual in here, and it says to install the pump cover and attaching bolts and torque to 60 to 80 inch-pounds. And remember that, inch-pounds. I had a guy call me up one time, says, man, I broke off all the oil pan bolts in my engine. I said, all of them? He says, yeah, they kept breaking. I was torquing exactly what it said. And I said, well, what did it say? He said, well, it was like, 60 pounds. And I said, yeah, 60 inch-pounds, right? And there was a long silence. Oh, he had torqued him to 60 foot-pounds, and of course, the end result was predictable. So, it is 60 inch-pounds. You will need an inch-pound wrench. I'm going to dig out mine here in a minute after I kind of hand tighten these. Our goal here is that these gears should turn relatively easy with our screwdriver. Now, of course, we have no distributor in this housing, and that is what you can do on the Corvair engine that you're working on, is take the distributor out. Now, pay attention to where the rotor is pointed before you take it out, and if you put it back in the same place without turning the engine, you won't be really far off on it where it belongs. So pay attention to that. Okay, we'll get our torque wrench here in a moment. Just kind of snugging these a little bit. This one's a little tight. We're going to take that out and clean that hole out of there. Okay, so we've completed torquing up our cover with our inch-pound torque wrench. And the test we're going to do is to see if we can turn the gears via the distributor drive. Obviously, I'm just using a screwdriver here, so we would put it in the rear housing, just where the distributor would go, and we'd try and turn it. And as you can see, it ain't turning. Okay, that gasket that we used, the let's see, which one was it? The 3,000ths is too tight. So I'm going to swap this out for the 5,000ths and see how it turns. And then if that one's too tight, I'll swap in the 8,000ths, and we can go all the way up to the 10,000ths one. Remember, we want to be in a fairly close range. Our desired clearance between the gears and the end cover is going to be like from 2 to 4. That's our really optimum range that we want to be at. The greater the number that we end up with, the less potential oil pressure we'll have, especially at idle with a hot engine. Okay, so we want to try and get as much as we can out of the stock pump. So setup is very important in it. So I'm going to switch this out and we'll try it again. Okay, now with our 8,000ths gasket in there, we got it to turn. It's not super duper easy. Might be a little too tight. So let's measure it and see, because our next step up in the gaskets is going to be 1, 2, 3, 10 thousandths. So 2 thousandths more than we've got now. So let's just kind of check and see what our clearance is. And like I had mentioned before, what we're going to use is some Plastigauge, which is a thin little plastic strip we stick in between the parts and we tighten it down without turning it, very important, and then we take it back apart and see how far the little Plastigauge squished out. Okay, this is available in a couple different sizes. There's different colors. There's the green Plastigauge, which is for measuring 1 thousandths to 3 thousandths, which is what we want. There's also the blue, which is from 4 thousandths to 9 thousandths. And there's also the red, which is from, let's see, where was her? 2 thousandths to 6 thousandths. So really either the green or the red would be suitable for what we're trying to do now. All right, let's try the red. Yep, our red's here. What I'm going to do is add just a little drop of oil on here to keep it in place while we tighten it up. We don't want it to move around. Now, I could have just turned this housing so it was straight on here, which is okay if you got the housing off. A little tough to do when it's assembled in the car. So that's why I wanted to show you about adding a bit of oil here to it so that you could do this too to keep that in place while you're tightening it up. So I want to align the gears here so that I'm getting a maximum contact area that we can actually measure on here. And again, we're going to try and move this as least as possible to get our actual measurement. So, our Plastigauge has squished out in here in the places where the gears were touching, and we can see that they were touching at this point and at this point. So we try and match up the width of the Plastigauge to the wrapping that it came with. So we see that on this gear, in a part where the cover was worn the most, it shows we've got, a little more than 2 thousandths on here. We're a little bit more than the width, or a little bit. The Plastigauge is not quite as wide as the 2,000 squish on the chart. And on this other gear, we're pretty much the same point. So we've got 2 thousandths clearance on these gears on here. And that's pretty much optimum. At 2,000, that's great. If we were in the 2 to 4 range, that's where we want to be. If we were at it hardly squished it at all, we'd go back to a lower number, but we eliminated that process by being able to try and turn the gears without even measuring them. If you can't turn them at all, you know it's too tight. You just know it's too tight. Or let's say we had gone to the 10 thousandths gear or gasket right away, then our we would have probably been around the 4 thousandths mark on here. The width squishes, you just measure by the wrapper. And using a gasket that was 2/1000 thicker would have shown up as 2/1000 difference on our gauge. So that's how we use the plastic gauge to verify our numbers. Since the gaskets come in these variety, Clark's has an assortment, one of each of these sizes that we had, which was the 3/1000s, 5/1000s, 8/1000s, and 10/1000s. So it's roughly 2/1000 difference between all of them. You know, I would recommend getting the assortment set for sure. In fact, I'd get 2 assortment sets. They're not very expensive, and that way you got it on the shelf in case you damage one accidentally or something. And put the one that gives you 2 to 4 in there, and that'll be really optimum to get the best amount of oil pressure. So now that we know which gasket we want to use on here, we'll clean everything back up and then final assemble this oil pump assembly. If you took out your distributor to check it by using the screwdriver, go ahead and put your distributor back in. You know, because of the gear set, it's got, you know, like a slot in it, and that's what the distributor turns. You may have to turn the rotor on our distributor some to engage that slot on the oil pump, so it'll go down all the way. And then remember, eventually you want the rotor to be pointing to where it was before you took the distributor out. And of course, the angle of the vacuum advance should be about where it normally sits. That'll get you close enough to start the engine and reset the timing. But make sure that the distributor, after it's put in, it's seated all the way down. And there's a gasket under here. You should have that gasket too. You might as well get that while you're ordering the oil pump gaskets. Make sure it's seated all the way down, because if the oil pump slot is not lined up with the distributor slot, it won't let you push it down all the way. So you got to make sure that sometimes you may need to turn the crankshaft back and forth a little bit until the distributor gear will line up with the oil slot. So that's pretty easy, standard operation for getting the distributor back. So that's really what I wanted to show you today, was how to fix this pesky leak of the oil pump idler shaft, because that's not covered in any of the shop manuals. It's out there in some of the Corsa Tech guides. People have also welded this entire area up. Heliarc welded it. I don't know that. I guess if you're a really, really good welder, you can do that. It's going to heat up this whole area. I'd be a little concerned about distorting the dimensions of here, because we're not dealing with a super thick area. But people have done that too, to try and cover this area up so that there is no open top to it. I think this is a more sure way to keep our dimensions right in the oil pump, and something that you can do at home without, you know, if you don't happen to be an excellent TIG welder or you know, have the equipment to do that, you can do this pretty simple with the Loctite or Permatex product. So that's all from me today. Happy leak-free driving.